carry it every day. You use it without thinking. It learns what you watch, where you want to go, and sometimes what you might want next. Behind much of it is a word you hear all the time: algorithm. But what exactly is an algorithm? At its simplest, it is a way of solving a problem, one step at a time. Today, algorithms run the digital world. But the idea behind them is much older than the computer. Much, much older. Baghdad. More than 1,000 years ago, this was a city where knowledge was not simply preserved. It was being gathered, translated, questioned, and transformed. Across the Abbasid world, scholars studied the mathematics of earlier civilizations, the astronomy of the Greeks and Indians, and the practical problems of everyday life. And somewhere within this intellectual world was a scholar from Khwarizm. His name was Muhammad ibn Musa Al-Khwarizmi. He studied numbers, but he was interested in something much bigger than numbers themselves. He wanted to know how a difficult problem could be turned into a method that could be understood, a method that could be followed, and, most importantly, a method that could be repeated. That simple idea would change the history of mathematics, and eventually it would leave an echo far beyond mathematics itself. Today, we would simply write an equation, add a symbol, move a number, follow a formula. But Al-Khwarizmi lived in a world before modern algebraic symbols. There was no familiar x, no x squared. Al-Khwarizmi did not write it like this: x squared plus 10x equals 39. He had no modern algebraic symbols. Instead, mathematical problems are expressed in words. For example, for one problem he wrote, 1 square and 10 roots of the same amount to 39 dirhams. That is to say, what must be the square, which, when increased by 10 of its own roots, amounts to 39? Al-Khwarizmi's method of solving linear and quadratic equations worked by first reducing the equation to one of 6 standard forms, where b and c are positive integers. By dividing out the coefficient of the square and using the 2 operations al-jabr, restoring or completion, and al-muqabala, balancing. Al-jabr is the process of removing negative units, roots, and squares from the equation by adding the same quantity to each side. For example, x squared equals 40x minus 4x squared is reduced to 5x squared equals 40x. Al-muqabala is the process of bringing quantities of the same type to the same side of the equation. For example, x squared plus 14 equals x plus 5 is reduced to x squared plus 9 equals x. But there is something remarkable about Al-Khwarizmi's legacy. His mathematics did not simply travel through books. His name traveled with it. At first, the word referred to methods of calculation using the Hindu Arabic numerals. As his works moved from the Islamic world into medieval Europe, his name was written in Latinized forms,
Al-Khwarizmi, and eventually another word emerged from that name, algorithm.
But if we remember Al-Khwarizmi only for algebra, we miss much of the story. Because mathematics was only one part of his work. Al-Khwarizmi's most significant astronomical achievement was the creation of an extensive set of tables known as Zij al-Sindind, astronomical tables of India. It became essential tools for subsequent generations of astronomers. These tables enabled precise calculations for predicting astronomical events, such as eclipses and the positions of celestial bodies, which were crucial for navigation and timekeeping. Al-Khwarizmi's third major work is his Kitab Surat al-Ard, Book of the Description of the Earth, also known as his Geography, which was finished in 833. It is a major reworking of Ptolemy's 2nd century geography, consisting of a list of 2,402 coordinates of cities and other geographical features, following a general introduction. Algebra, the compendious book on calculation by completion and balancing. Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala is a mathematical book written approximately 820 CE. It was written with the encouragement of Caliph al-Ma'mun. Applications to a range of problems in trade, surveying, and legal inheritance. The term algebra is derived from the name of one of the basic operations with equations, al-Jabr, meaning restoration, referring to adding a number to both sides of the equation to consolidate or cancel terms.
And perhaps that is why, over the centuries, his story became so powerful. Powerful enough that new claims began to grow around his name.
But how much of the story is actually true? Let's find out. Let's start with one of the most common claims. Al-Khwarizmi invented zero. But history tells us something more complicated. The mathematical concept and use of zero developed in India before Al-Khwarizmi's time. So no, he did not invent zero. His work belongs to the later transmission and development of the Hindu-Arabic mathematical tradition. This one is closer to the truth, but still too simple. People were solving mathematical problems long before Al-Khwarizmi. Babylonian and Indian mathematicians had already developed sophisticated methods. What makes Al-Khwarizmi so important is how he organized methods for solving equations systematically. His famous work, Al-Jabr wal-Muqabala, became one of the major milestones in the history of algebra. And from Al-Jabr came the word algebra. Did Al-Khwarizmi invent the algorithm? Not in the modern sense. Step-by-step procedures existed long before him. But here, something remarkable really did happen. When his name was written in Latin, it appeared in forms such as algorithmi. And centuries later, this linguistic journey contributed to the word algorithm. No, he did not build a computer. He lived more than 1,000 years before electronic computing. There is no direct line from Al-Khwarizmi to your smartphone. But there is a reason people make the connection. His work belongs to a long history of systematic calculation and procedures for solving problems. Centuries later, algorithms became fundamental to computing. But that is a lineage of ideas, not a direct invention. Today, you rarely see the algorithm itself. You simply see the result. A recommendation, a route, a search result, an answer. But underneath, there are instructions. But we should be careful. This does not mean Al-Khwarizmi somehow knew what a computer would become. He couldn't have. He lived more than 1,000 years before the digital age. What connects him to our world is not a machine, but a way of thinking. Perhaps this is what an echo through time really looks like. Not a voice repeating the exact same words, but an idea, traveling farther than the person who first carried it. Al-Khwarizmi lived in the 9th century. His world is gone. His library is gone. His voice is gone. But the method survived. A man disappeared. An idea remained. And now, we're back where we started. 1,000 years separate us from Al-Khwarizmi. Yet every day, we use systems built around instructions, calculations, and algorithms. But perhaps the most interesting question isn't what algorithm is controlling your screen. It's this: how do you solve a problem? Maybe the lesson Al-Khwarizmi leaves us isn't about computers at all. Maybe it's about the way we approach complexity. Take the problem. Understand what you know. Break it into steps. And keep going until the answer becomes clear. Al-Khwarizmi lived more than 1,000 years ago. We don't have his voice. We don't have a recording of his thoughts. But we can still hear something from him in the questions he taught us to ask. How can a problem be understood? How can it be simplified? And how can a solution be followed? How do we turn a difficult problem into a path toward an answer? If you enjoy uncovering the stories hidden behind the world we live in, subscribe to Echoes Through Time. Because history doesn't disappear, it echoes.